So a new unit is systems of equations, my favorite stuff. So a system of equations is two or more equations. We are going to be using two, but the actual definition is two or more equations. And we're looking for where they meet. So systems of equations is just generally we're talking about two or more equations. When we talk about a system, sometimes they meet, sometimes they don't. So the point xy where two lines meet, that is our solution, and it's the point that makes both equations true. Sometimes we'll have parallel lines, so they're never going to meet. So we can have intersecting lines. They can intersect at some point. We end up with one solution. Parallel lines, those are not the best. Let's make some actual parallel lines. So you can have two lines that are parallel to each other, and they're just never going to meet. It's not going to have a solution. Or sometimes we'll have the same line, so you'll have a line, and then you'll get another line that maybe is in a different form, that it doesn't look like it's the same line, but it ends up being the same line. And so then our solutions would be that entire line. So it'd be infinite amount of solutions. So solving systems by graphing, the first thing we're going to do is put both equations into slope-intercept form. We want that so they're both a y equals, because then I can do the second thing, which is to graph the equations. And then the last thing that we're going to be doing is we're going to find where they meet. So now we're going back to the things we did, some of the things we did in the first unit, where we're looking at graphing lines, writing lines into the y equals format, so taking them from different forms and putting them into the slope-intercept format just to be able to see. So when I'm graphing them, I often like to use different colors. I find that's helpful. So I'm going to start at -8, because that is my y-intercept, so remembering kind of how that works. My slope would be 1 over 1, so I go up 1 over 1. And I would put a dot. I need to keep doing that the whole time. I want to make sure that I'm accurate where my lines are. And I should have lines going the whole way. And then I'm going to graph my second line. So I start at the y-intercept of 1. My slope is -2, so down 2 over 1. And I could go both directions. I can already see where they meet, but I am still looking at, are you graphing those lines correctly? Because those of you who didn't do that well in the first part, then I kind of can see whether or not you want to have that particular skill. Then I'm looking for that intersection point, and that intersection point happens to be at 3, -5. So that's where my solution to this particular graph set is. Let's look at, I'm just going to go down and look at number 3. These are not in that slope-intercept form. So what I need to do is I need to change them. And if I look at this first one, if I add 3x to both sides, I can have my equation right here, and these would be gone. And here I need to add x. So I'd have my equation here, and these would now be gone, and they would equal 0. I don't have to divide by anything in front of y because it's just a 1. So graphing those, this first line here, my y-intercept is at 8. I know it's the y-intercept because there's no x value. My slope is up 3 over 1. I can kind of see where it's supposed to go, but I'd go down 3 left 1 as well, and I can get my graphs there. And then I'm going to connect those dots. And my second line, starting at the y-intercept of -2, up 1 over 1. All the lines, if I give you a piece of graph paper, they're all going to meet in that graph paper. If they don't, that means somewhere you are making a mistake. So just double check kind of what you have. Did you make your slope positive, negative? Did you do those pieces that you were supposed to do? I'm not going to worry about that line not being exactly where I want it. I can see where my intersection point is, and it's at -1, 2, 3, 4, -5, and down 1, 2, 3, 4, 5, 6, 7. So -5, -7. Let's look at 5, and then I'll have you should be able to kind of just check your answers from there. So 5 has this y equals -7. I'm going to graph that one first just because it's all ready for me to go. I go to -7. And there's no slope. So it's like up 0 over 1, up 0 over 1, or it's just this horizontal line going both directions. Again, make sure you're graphing out your full line because I am grading that graphing piece. The next one, I'm going to go ahead and rewrite. And so I'm going to do minus x to both sides. Then I still need to get y all by itself, so I need to divide by 3. And remember, we do that to both terms. So I get y equals -5 minus 1/3 x. When I'm pulling out that number in front of x, it's just like a -1, so I can pull out that fraction and be left with just an x. Then when I graph it, I start at -5. And I'm going to go up 1 to the left 3, because I need to make sure that I have a negative slope. And down 1 to the right 3. I can see where my intersection point is, but because that's not the only skill I'm grading you on, I want you to complete that graph. And those two graphs meet at 1, 2, 3, 4, 5, 6. And down 1, 2, 3, 4, 5, 6, 7. So graphing, again, I'm just graphing out 2 lines. So it's good practice for how to graph. And then I'm going ahead and writing those. I'm noticing in number 8, I just want to do this first one for you. If x equals -2, that's just a vertical line at -2. All those places are what x equals -2. And then you're going to convert the other one in graphs, and then you check your answers.